Okay, so let's go over your answers to the group warm-up for numbers 1 through 4. In front of you, I posted the answer key to Blackboard assignment number 8. This is the unit circle we covered in class on Tuesday, November 22nd, but you can also have these same values for the lesson 3 notes that we covered the week before. Either unit circle would be sufficient enough to get you the answers that you need for numbers 1 through 4 in this group warm-up. So in number 1, cosine of 90 degrees, if I locate where 90 degrees is, I have an ordered pair that represents that special angle. And we also know from class that each ordered pair around our unit circle can also be expressed as cosine as my x value and sine as my y value. So if I look at 90 degrees at 0, 1, I know that cosine of 90 degrees is going to be represented by that first value. So cosine of 90 degrees should be 0 for number 1. Number 2, your sine of 60 degrees. If I locate where 60 degrees is on my unit circle, I also have another ordered pair that represents that special angle. Since I'm looking for the sine of 60 degrees, I'm looking for the second value in my ordered pair. So the sine of 60 degrees should give you square root of 3 over 2. In number 3, sine of 240 degrees, if I go around my unit circle, I also have an ordered pair for that special angle. And I'm looking for the sine value, which is the second value in my ordered pair. So the sine of 240 degrees should be negative square root of 3 over 2. And if I look for number 4, cosine of 300 degrees, if I find that angle and that ordered pair, since I'm looking for cosine, I'm looking for the first value, so cosine of 300 degrees should be 1/2. So if I zoom in, cosine of 90 degrees, you should have written down is 0. Sine of 60 degrees, you should have written down as a square root of 3 over 2. Sine of 240 degrees, we should have negative square root of 3 over 2. And cosine of 300 degrees, you should have as 1/2. So hopefully your answers for numbers 1 through 4 matched up pretty closely to our answers for numbers 1 through 4 using the unit circle. Moving on, today we're going to talk about radian measure. So our lesson 4 notes are going to talk about this concept today. It should only be 2 pages long. And up to this point, we've worked with angles being measured in degrees. Our unit circle is measured in degrees. The right trig that we've been using since the beginning of the year has been measured in degrees. So today we're going to talk about the other way we can measure angles. You may want to spell that correctly on your paper. It should be LES instead of ELS. But we're going to talk about the other way we can measure angles, which is called radians. So what are radians? I'm going to zoom out a little bit here and refocus. To define a radian, consider a circle with radius r centered at the origin. So over here on the right, we have a description. And a radian is basically the ratio between the length of an arc and its radius. So in other words, an angle of 1 radian results in an arc with a length equal to the radius of that circle. So this value right here from the radius of the center to the outer edge of your circle and the distance of that point to your x-axis, those two values are going to be the same. So in other words, 1 radian is the measure of an angle in standard position whose terminal side intercepts the arc of length r, which is the same length r. So your radius length and the length of your arc are going to be the same. That's what a radian is. I like to think of radians and degrees, the relationship between the two, similar to the relationship between a fraction and a decimal. Fractions and decimals mean the same thing, but they're in 2 different forms. Radians and degrees are kind of like that, in which they mean the same thing, but they're in 2 different forms. Now that we know what a radian is, we can look at the relationship between radians and degrees. So back in the day, and I'm sure it hasn't been too long, you learned what the circumference of a circle is, and basically it's the distance all the way around your circle. And you know your circumference of a circle to be 2 pi r. And with your circumference being 2 pi r, basically this means that your radius